Hello everyone. In this tutorial I'm gonna be covering a small tutorial about Gmsh. I will create a 3D cylinder, roughly speaking a cylinder with a hole in it, an annulus, and I will associate at the end a mesh to it. So first let's start by opening the application Gmsh, and since it doesn't create automatically a file, we'll need to associate to it a new file by going to file and new, and then let's call it cylinder. I'm gonna save it in the desktop and save. And here it tells us that we need to create a geo extension, so we'll do it, and I will use the built-in kernel. All right, so let's zoom in here and go full screen. And for this geometry I need to create two circles. To do so, I need to create 4 points for each circle and an origin as well. So we need to head over to geometry, then elementary entities, then add, and here we can find all the entities that we need to create a domain. For our case, we need to select point, and then the origin will be, oops, what's this? Whatever. So the origin will be 0, 0. We'll add it. Then the small circle will be of radius 0.5. So let's say that we create the point 1, 0, then 1, let's say 0, 0, okay. So 0, 1, like that, 0, -1, and -1, 0. And then for the big circle, let's say that it's of radius 5. So we'll start by adding the point 10, 0, and then -10, 0, then 0, 10, and the last point will be 0, -10. Alright, now since we finished, we can click on Q to abort this window. And to create the circles now, we don't need to select circle. Instead, we select circle arc, and this can specify more domains for later on purposes, especially for meshes, if we need to create a few types of meshes in the same domain, as we're gonna do later on. So let's select circle arc, and all right, there's okay. So to create the first arc of the big circle, select a point, then the origin, then another point. Similarly, we continue to create the second arc, the third one, and the last one. And similarly for the small circle, same process here. Alright, and since we finished this step, we can press Q to abort. And now the idea here is to create a structured mesh in this region of the domain, and then the remaining region will get an unstructured mesh. So in this case, I need to separate those regions. To do so, I need to create lines. So I'm gonna join those 2 points like that to create the first line. The second line will be done in the same way, Similarly here and here. All right, we can click on Q to abort, and let's for the sake of clarity, I need to get rid of the grid, and this can be done by going to tools, then options, and then general in this tab, and then access. The full grid needs to be switched to none. In this case it's clearer. For the moment I'm still working in 2D, but later on it's gonna be extended to 3D. But let me show you a few quirks here because they are important, and we need to complete the job before going to 3D because it's just a generalization. So to be able to precise the type of meshes, we need to specify a surface. So it's the inside of this domain. And to do so, we need to click on plane surface, and we need to determine each region where the mesh will be different from the other regions. So for my case, since I want to create a particular mesh in this region, I will specify this one here first. So here, after selecting the boundaries, it tells us that if there is a hole, we need to select it. But in my case, there is no hole in this region, so we're good. We can press on E. And as you notice here, we get those two lines just tell us that the surface has been created. I can do the same thing for the three remaining regions. So let's do it. So this is the first one. There's no hole in it. The second one, and the remaining region here. So here I created all surfaces, and I'm ready to press Q to abort. Alright, so this one was just for the surfaces, and I can show you here, I can create immediately mesh by pressing on 2D. But as you see here, we get the same type of mesh in the whole domain. In this case, I need to just modify this one and keep the other ones untouched. But before that, let me show you that there is a way to do a refinement or whatever, just to play around with the size of the scale of the mesh. And this can be done through tools, options, and then going to mesh, then general. And here, as you see, we have element size factor. This can be switched to a smaller one or bigger one. Let's say, for instance, 0.2. This is gonna refine the mesh. So we can hit reload, then 2D, and as you see, we get a finer mesh, and so on. So for the sake of clarity, I will just switch to 1 because it's more visible to us. All right. So here, just reload is to get rid of the mesh and to go back to the state to where we were at the first. All right. So to modify the type of mesh in this region, let's head over to define. It's under mesh, and we need to select transfinite. And first, let's select the curve, and for this one we need to select the boundary, roughly speaking. So this is the boundary of our region, and here we have several options. So let's not touch the second and the third options. And here the first one is what is important to us. 10 means the number of nodes per curve, let's say. So here I select 10. So on this curve I have 10 nodes, and so there is on this curve as well as on this and on this. So 10 by 10 by 10 by 10, and those nodes will be connected to those nodes, and those nodes of this curve will be connected to those nodes of this curve. All right, so now since we finished creating this, we can hit E and then Q to abort. In this case, let's just show you what we create as a mesh. All right, there's nothing, roughly speaking. There's some variation here, some variation on the boundary, let's say, because we have just 10 nodes as I spoke before. All right, so reload and let's carry on. We are underneath the transfinite. I already did curve, and then let's hit on surface, and here I need to just select the surface, and then as Gmsh tells us here, we need to select the boundary points, but it should be ordered. This means that I can create the first point here, select the first one, the second one, the third one, and the fourth one, and then hit E, then Q. This one here, in this case, it changed entirely the mesh type. We can hit on 2D and it's apparent. But since I need to be structured, I need to get rid of these diagonals of each rectangle. To do so, first I need to reload the script and hit recombine, and I need to select the surface and hit E, then Q, and let's see how the mesh will turn out. Exactly, this is what I want. All right, so this was the first step of this tutorial. Of course, we can play on the number of nodes here. We can add, let's say 20 nodes per curve, and this can be done by clicking on edit script. So here, every time we click on something, there is a hidden script created, and it's a code, roughly speaking. So if we type, or if we hit the edit script, we get what we created so far. We have the points, we have the circles. We don't have 8 circles, but we have, for each circle here we have an arc, so 4 arcs for each circle. It makes sense. Then the lines, so on so far, and we get that transfinite curve that I did, and we get this scale 10. We can change it. For instance, we can, let's say, put it 20, and of course we need to save this script and go back to Gmsh, reload the script, and then mesh 2D. As you notice here, we get a finer mesh. All right. Okay, so I'm gonna go back to the previous case where I had 10 nodes per curve. Save, then go back to the script, reload. The reload step here is essential because we want to apply the changes that occurred. And then to get a mesh, we need to press on 2D, and this is it. All right. So now I think we are ready to go to 3D. First, let's reload to get rid of the mesh, and we need to extend this domain to 3D. To do so, we need to go to geometry, then elementary entities, then extrude. And this extrude, we have the translate option. We press on it, and let's say that we need a a cylinder of height 10. So in the direction of Z, we only need to precise that it's 10, and we don't need to modify the first two cases. And then I want to extend the mesh that I've created. So we need to extrude mesh here, select it, and we can specify how many layers we can create. For my case, I can just specify one mesh. I will show you later on if I modify this number to another number, it can give us as many layers as we want. And then we want to extend all entities. So here we have all entities, we have points, we have curves, volumes. For my case, I want to extend all entities, so I will keep it like that, and I will select everything from curves to points to surfaces, everything. Hopefully I will not forget anything. But since the origin doesn't play any role, we can keep it like that. We don't need to select it. And don't forget about the surfaces. Alright, so we hit E in this case, and then Q, and we can tilt the domain. We can see that it has been extended to 3D. Of course, here we can take a look at the mesh. In this case, since we are in 3D, we don't need to hit 2D. We press on 3D to get the mesh. Alright, so as you notice, we get the same type of mesh in this region and the same type of mesh in the remaining regions. Alright, so as I was speaking previously, I can create as many layers as I want. For instance, I can create a few layers here vertically. And to do so, let me just reload the script and go to edit script as before, as I did. And here we can see that there's an extrude command that was created. And here I have the layer. Let's modify it to 10, for instance, and save it. And go back to the application. Of course, we need to reload first and then 3D. And as you see here, we got 10 layers. They are not so apparent, but we can count them 1, 2, 3, 4, and so on to get to 10 layers, and we maintain the same type of meshes. Alright, so in this case, let's make it simpler. I'm gonna go back to the script here and modify this to 1. Here there's everything. You see here I precise curve, all the curves, all the points, all the surfaces, and yes, so save and go back and reload. And alright, we still need to specify the physical domain or physical groups, and this is important, especially if you want to export this file to use it in a solver. So in this case, let's get rid of the mesh here. We only need to go to the physical groups here and start to add them. For instance, let's say that we have a force that is applied to the top of our domain. So to determine the top of our domain, we refer to the coordinate system. We have Z as a vertical axis. So the top of our domain is this layer here. the upper layer. And to be able to specify this top, we head over to physical groups and then add. And since we are working in 3D, obviously it's a surface. If we were working in 2 dimensions, it would have been a curve, and so on. So we press on surface, and let's say that it's called top. And it remains to select the 4 regions of this surface. We'll make sure that it's correct, and then select E. We press on E. Then let's say that there's another force applied to the bottom of the cylinder. We can do the same process. This time it's called bottom. We select the 4 regions as well. Here it's a little bit complicated. We need to be precise. Alright, and then we hit E, then Q to abort. In this case, I specified both physical groups, which are at the top and the bottom. However, in this case, if we add the mesh and then try to use this domain and its mesh in a solver, it will be considered as a 2D mesh or a 2D domain. There's something weird about it. To get rid of this, all we need to do is to add a physical group, which is a volume. So in this case, we guarantee that we are working with a 3D domain and not a 2D domain. So volume, let's say that it's called cylinder, and we need to select the 4 volumes which make up our domain. Then press on E and then Q, and that's it. So I think in this case we are done. We only need to make sure that everything is correct, the mesh is good, and alright, so let's reload, and I think it's time to us to export what we've done. And alright, so here's an important step. Before exporting, we need to mesh the domain, because we need to be well structured. Otherwise we get nothing in the exported file. So press on 3D, then to export the file, all we need to do is hit on file, then export. And what we need to do is specify the name of our file, and then we need an extension, and here it depends on the solver. For instance, here we have as many extensions as we want, and for my case, let's say for instance I will need an abacus extension. It's INP. We can either press on INP, or we can just add it in the file name .inp, and it can guess from an extension what is the file type. Alright, so save, and here we have 2 options. The first one is to save all elements, so the mesh elements. The second one is to save the groups of nodes. The groups of nodes are the physical groups that we did before. So it's the top and the bottom and the whole volume, which is the cylinder. It's very important to select this one. The first one is not that important, we can do it, but since we already determined the physical groups, we can ignore the first one and then just hit OK. Alright, we can visualize this this file. I think it should be alright, it should be somewhere. It should be, what am I doing? Okay, so we exported the file, its type is INP in my case. It could be something else, but what is important is its content. So I will open it through a text editor. Hopefully I can find the text editor here. Yes, this one. Alright, so here we have in the first section the nodes, And on the first line, the first column here, we have the number of nodes created in the domain. So this, as we see here, we have 822 nodes. Then we have the surfaces. I guess we should get 8 surfaces, 4 for each surface. So for the top, for instance, we have 4 surfaces because it consists of 4 regions, and the same for the bottom. So the first, second, so surface number 3, 4, 5, 6, 7, and 8. All right. So why did I come back to the nodes? I don't know, but it was the 8th one here. Okay, and then we have the volume, which is the cylinder as a whole domain. And we notice we have more nodes here. So here, just to explain it a little bit, for instance, let's take this one, the first element of the volume one. The first element here consists of 1, 2, 3, 4, 5, 6, 7, 8 nodes, and it's apparent here in the type of the element C3D8. 8 is a reference to the number of nodes per element. All right. We have 4 volumes because, as I mentioned before, if I go back to Gmsh, we have those yellow balls. This means that we have 4 volumes. And what do we have as well? I don't know why it's going like that, but we have the top. This is the surface here, and the bottom. This is what's important. All right. So we go back to Gmsh, and I think the tutorial is over. Hopefully I didn't forget anything, and I hope this was useful for you. If you have any question, just you can leave them in the comment section below, and take care.